The purpose of this lab is to use Newton's second law to predict the motion of an object with constant velocity. For my object, I chose a cardboard tube, and I decided to roll it across a desk. The different forces acting upon the tube are the downward force of the Earth's gravity and the upward force of the desk. I am assuming that they cancel out, leaving a net force of 0. There might also be some air resistance, but that is so small that I will ignore it for this experiment. I measured the diameter of the tube to be 8.6 centimeters, or 0.086 meters. I used that for the length scale in the Tracker program. For the axis in Tracker, I chose to orient the direction of the motion in the positive x direction. If I had chosen to orient it in the negative x direction, the resulting graph would have a downward slope rather than an upward one. Using the data in Tracker, I was able to calculate the initial velocity of the cardboard tube. Since the cardboard tube started out at time 0 and at position 0 in the x direction, I simply divided the position in the first frame by the time of the first frame, and that gave me an initial velocity of 0.3 meters per second. Using the VIDLE coding program, I plugged that information in, and I got out this model. I also got a set of coordinates corresponding to that model. I took the data from the model in VIDLE as well as the experimental data from Tracker, and I put them both in the same graph. This is a graph showing the velocity of the object over time, measured in meters per second. Although the velocities started out similarly, the experimental velocity decreased over time. At the final time of 1.37 seconds, the tube had traveled 0.28 meters. However, the model predicted that the tube should have traveled 0.41 meters. That means the model predicted that the cardboard tube should have traveled 1.28 meters farther than it actually did. That's a difference of over 1/8 of a meter. Since there was a difference between the two datasets, the net force upon the cardboard tube during the experiment must not have been 0. There are a few factors that could have caused this force upon the cardboard tube. I discovered that the desk itself is not completely level. There is an area that is slightly lower than the rest. This would explain why the tube went faster at first, and then its velocity decreased after it passed the low spot. In addition, the surface of the tube itself is not completely smooth. The cardboard is a bit rough and probably caused more friction, which would also affect the velocity. If I were to do this experiment over, I would choose a smoother object and a more level surface area. If I did, a graph of the experimental velocity probably would align more with the model graph than my experimental graph did. Thank you.